Exercise 2. Create a ballast layer and null points. In this exercise, we'll use precision import to create the ballast layer from a constrained component. We will also create null points that represent the left and right rails and also the rail centerline point. So we are in the Create Template window. We have our dynamic settings window open, and on the components folder I'm going to right click and go new template. I'm going to call this single track ballast. And first of all, in the Create Template window, we are going to create the 3 null points that represent the left rail, the center rail position, and the right rail. On the dynamic settings panel, because you make sure you set the step values for both X and Y to 0.01. The point name, can you set that to rail underscore CL? And the feature definition, we're going to go to linear, template points, rail, and pick the TL rail center. The precision import, we're going to set to XY. And with the precision input set to XY, this is going to be measured, the points can be measured from the absolute coordinates of the template origin. So first of all, in the Create Template window, I'm just going to right click, add new component, and select null point. In the XY value, I'm just going to type in 0, 0 and hit enter. And you can see that places the rail CL point at the template origin. We're now going to create the rail right point. So in the template window, can you right click, add new component, null point. Change the point name to rail right. The XY value, the horizontal distance is 0.7176, 0. Hit enter. Again, in the Create Template window, right click, add new component, null point. Change the point name to rail left. Leave the feature definition the same, and the XY value, the horizontal distance is minus this time because it's to the left of the rail CL point. And the value for the Y is 0. Hit enter. And file and save. We're now going to create the ballast layer underneath the rail null points. To create the ballast layer, we're going to use a constrained component. So again, in the template window, right click, add new component, and set this to be constrained. The component name at the bottom, we're going to call this ballast, and the feature definition is going to be set to mesh rail TC ballast. You'll notice there's a point on the end of the cursor. So in the point name here, we're going to set this to rail ballast. So from the list, we're going to pick rail ballast. The feature definition should be rail ballast, and it is. Again, we're going to do XY, which is to place a point with relation to the dynamic origin. So the horizontal distance is 1.625, and the Y distance is a negative because it's down, so it's minus 0.172. 8. And again, hit enter. And that point is now placed. We're going to continue placing the ballast points. I'm going to leave the point name the same and the feature definition the same. This time the precision input is going to be horizontal and slope. And the distance is going to be minus 3.25 because it's to the left. And the top of the ballast layer is flat, so there's no slope. So that's a HS minus 3.25 with a 0 slope. Again, hit enter. We're now going to place the first side slope of our ballast layer. And again, I'm going to leave the ballast point name the same. Again, I'm going to do it by precision input of HS, horizontal and slope. And the value is minus 0.37, comma, 50.0%. And again, hit enter. If you hit the fit view, you'll be able to see the definition of the template easier. And the last point we're going to place is the point over here. And again, we're going to use HS, and the value is going to be 3.85 with a slope of 0. And again, hit enter and right click and finish. And again, at that point, I'm just going to go to the File and Save option. The next thing we're going to do, we're going to insert a point at the midpoint on the bottom ballast layer component line so that the bottom of the ballast layer drains. So place your cursor anywhere along the bottom ballast layer line, right click, insert point. Now I'm just going to keep it directly underneath the rail CL point. Wherever you place it, it doesn't really matter. So I'm just going to place it with a left click and then just right click and finish. I'm just going to change the names of some of these points to make them more realistic and so that we can identify them easier. So first of all, I'm going to select the point that we've just placed. So I'm just going to double click on it and we get to the point properties panel. And I'm going to change the name of this point so it says rail ballast underscore BOT, because that stands for bottom, underscore CL because it's underneath the CL point. Hit apply. Now I'm going to use the target graphical selector and I'm going to select the rail ballast point here. And I'm going to change the name to rail ballast underscore SHDR because it stands for the shoulder, and underscore right because it's on the right. Hit apply. Again, use the target graphical selector. Select rail ballast 1. Again, amend the name till it again says underscore SHDR underscore L because it's on the left, and again hit apply. Again, use the graphical selector, select rail ballast 2 point. Again, we're going to amend its name so it says underscore BOT for bottom underscore L. Hit apply. And the last one that we're going to do is this point over here. So again, use your target selector, pick the rail ballast 3 point, and again, amend it until it says BOT, which is again the bottom, underscore R. Hit apply, close. Hit the fit view option, and again, save the template. Now, several of the points within our single track ballast layer are green, which means they are unconstrained. And typically within a template, there is usually only one point that is unconstrained, and that is normally the point at the origin. So the next step is to add constraints to the points that are currently green but also we're going to amend some of the other values of the points that's red. So first of all, we're going to do the null points. So first of all, double click on the rail right point. And you can see here it has two constraints. So constraint 1 is going to be a slope. And we're going to constrain it using again the target selector from the rail CL. The slope is 0. Constraint 2 is going to be horizontal. Again, use the target selector, pick the rail CL as its parent point, and the offset is 0.7176, which is half your gauge width. Hit apply. From the pull down, from the target selector, again now pick the rail left point, and we're going to use the same values that we used for the rail right. So constraint 1 is slope, its parent point is rail CL, the value is 0. Hit apply. Constraint 2 is horizontal, its parent point is rail CL. Again, it's half the gauge width, but it's negative because it's to the left, and hit apply. The next point we're going to constrain is the rail ballast shoulder R point. So again, use a graphical selector to pick the point. Constraint 1 is horizontal. The parent point is rail CL. The value has already been placed in there by the software. Constraint 2, we want this to be what we call a vector offset, because at some point this track will be canted, and we want the top ballast line to follow the cant, and the left rail and the right rail are the points that are going to get canted. So vector offset means that this point will follow the same plane as the rail left and the rail right point. So that's going to be the parent points, rail left, rail right. And the value is 0.178, which is the height of your rail. Again, hit apply. All right, let's do the next one, which is a rail ballast shoulder. Again, select it. Now this already has constraints. Okay, so we are going to change the horizontal constraint, its parent point to rail CL. Hit apply. And again, constraint 1, we're going to change it to a vector offset for the same reason that we did the rail ballast shoulder. And its parent point again is going to be the rail left and the rail right point. And again, the value is the height of your rail. And just go apply. We now need to constrain the rail ballast bot CL point. So again, use your target selector. Pick the point. First of all, constraint 1, again, is going to be a vector offset. And we want it to follow the top ballast line. So the parent points are the rail ballast shoulder L, and the other parent point is the rail ballast shoulder R. And the value that we're going to put in here is going to be 0.11857. Hit apply. The point goes yellow because it's only got one parent point, one constraint. Its next constraint is going to be horizontal, and the parent point is rail CL. So we want it to line directly underneath the rail CL point, and hit apply. And then we've got one more to do, which is the rail ballast bot R point. So again, use your target selector, select that point, and this point is already constrained from the rail ballast bot L point over here. And it's a slope of 0%. But we want the slope of that side slope to be 50%. So we need to constrain it again by slope. The parent point is the rail ballast shoulder point, and the slope is going to be minus 50%. And hit apply and close, and again file and save your template library. And this completes exercise 2.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.